Following demonstration shows how stretched Oracle RAC deployed with VPLEX Metro provides continuous business operation, even in the event of a loss of connectivity to back-end storage. Our demonstration environment consists of Oracle 11G RAC 64-bit, 4 nodes of Oracle Enterprise Linux 5.6, EMC VPLEX Metro single engine at each site, running Geosynchrony 501, and then we're using Swingbench 2.4 to graphically illustrate the workload running on the Oracle database. The connection topology for our demonstration is as shown. Oracle nodes 1 and 2 are connected to the Hopkinton cluster, which leverages VMAX 1551 as storage on the back end. The second site, Boston, is connected to RAC nodes 3 and 4. As shown in the top right, VPLEX Witness has been deployed to provide guidance in the event of a WAN loss or site loss to the surviving cluster node. To simulate the distance between these sites, we've used a WAN emulator to add 1 millisecond of latency between our sites. Here's a simplified drawing illustrating the exact failure scenario we're about to demonstrate. Backend storage will be disconnected from the Hopkinton cluster. We'll do that by removing zoning, and then you'll be able to observe the response of Oracle RAC in this type of failure scenario. Each of the stretched Oracle nodes access VPLEX virtual volumes through a storage view. As you can see, there are 7 virtual volumes assigned to each of the Oracle RAC nodes. Consistency across those devices is maintained within a consistency group. In this case, the Oracle RAC CG maintains consistency across the volumes shown, and the detach rule is set for Hopkinton, and this will control what site remains running if the site's partition. The virtual volumes reside on top of distributed RAID 1 volumes. You can see that they consist of LUNs that reside in Boston and Hopkinton. You'll recall we have a 4-node cluster, so we're going to open up our command line to one of the Oracle RAC nodes, and we can see that there are in fact 4 nodes running, Oracle nodes 1, 2, 3, and 4. Next we'll go into Swingbench. For Swingbench, we've used the Oracle JDBC driver. We've assigned the username Zoe, and we're going to use 250 users for our demonstration. Now if we click Start, we'll see that all 250 users are logging in. Once they do, the 3-dimensional graph will start to populate with transactions, the customer registration, browse products, ordering, processing, and so forth will now be graphically illustrated. That will take a few minutes to populate, so let's take a look at some other aspects of our environment. I've got a SQL query that I've written and saved as a file. It selects from the instance IDs and counts how many sessions are logged into each. So this will give us a good idea of what the workload distribution is across each of the Oracle nodes in our RAC environment. Next we'll go into SQL Plus and we'll execute the query that I'd saved in that file. As you can see, we have approximately 62 to 65 sessions connected to each of the stretched nodes. So that's about what we expected for 250 users. Our transactions are now starting to stabilize across the environment, and we'll shortly be able to start our storage failure demonstration. Okay, it seems like it's stabilized now. Let's take one more last look at our VPLEX environment, confirm everything's healthy before we begin our failure scenario. The array we're going to fail is array 1551. Its current connectivity status shows that it's okay. And if we check the system status for the VPLEX Metro, we'll also see that both Boston and Hopkinton are showing green across the board. Our transactions have stabilized. So now we're ready to start our back-end storage failure. We're going to be using Brocade Fabric Manager to do this demonstration. The way that we'll achieve the failure is we'll remove the zoning for the back-end storage for 1551 from the Hopkinton VPLEX. So we'll remove it from the zone set. We'll then save the zone set with those zones removed. Once it's been saved, we'll now click on the Activate button, and this will make the zoning changes take effect. As you can see, we're removing 4 zones from the current zone set. Once this activation completes, I will have removed all storage connectivity to the storage array 1551 from Hopkinton. As we'd expect, the transaction level is dropping. This is due to backend I/O waiting, VPLEX trying to determine what's happened to backend storage. So transactions now need to wait. This drop-off lasts for approximately 20 seconds, and now we're down around 1,400 transactions per minute. We'll see that it's flattening out. VPLEX has now determined that array 1551 is gone, and now is continuing I/O transactions for the RAC cluster. You'll notice the transactions per minute is now starting to increase. And now it looks like it's well on its way to recovering from any delays that were caused during the loss of the entire array. If we take a look at VPLEX, we'll see that we do have an error showing in our system status. If we click on that error, we see that array 1551 has in fact lost connectivity to the VPLEX in Hopkinton. If we take a look at our distributed devices, we can see that the RAID 1 mirror leg for Hopkinton is showing warning that it's not able to connect to those LUNs. Our transactions per minute is now starting to stabilize. We're back around where we were prior to the array failure, and we'll also see that the distribution of connections across our nodes is the same as it was prior to the failure. As you've seen from the demonstration, there are a number of reasons to deploy Oracle Stretch RAC on top of VPLEX Metro. Oracle Stretch RAC becomes much easier to configure and manage when deployed with VPLEX Metro. VPLEX Metro provides continuous availability across multiple sites. Both sites are actively running workload, and there is no concept of failing over from one site to another as part of a test. As you saw, VPLEX also delivers the capability to non-disruptively move between storage frames and between sites to accommodate maintenance activities or the movement of data from slower performing to higher performing storage tiers. VPLEX also provides database consistency across multiple databases and also across the server and application stack that sits on top of Oracle. VPLEX can also be leveraged across other applications within your environment. It does not need to be exclusively dedicated to Oracle RAC. EMC VPLEX interoperates with EMC storage as well as third-party servers and storage arrays. To learn more, visit emc.com and search for Oracle Extended RAC with EMC VPLEX Metro, or contact your local EMC Oracle expert. EMC has experts in the field that can help you develop your Oracle and VPLEX solution. Thank you for taking the time to watch this demo.